All right, for today's math lesson, we're going to be looking at order of operations, specifically with decimals. Now, this isn't a decimals little mini unit, but order of operations, anytime you're doing a lesson on that, it applies to any type of number. There's no special order of operations for whole numbers, and then a different order for fractions, and then a different order for decimals. Order of operations is universal. It applies to every and all math problems that you do, regardless of the type of numbers. So as much as this is a look at decimals, this is also a look at order of operations. So my key ideas or quick tips or big ideas for today are simple. Always follow PEMDAS. Now, I say PEMDAS. I know other people will teach it slightly different ways. Some people say GEMDAS. The G stands for grouping instead of P for parentheses. There's a couple other ways as well, but ultimately, the first thing you need to look for is any type of parentheses or grouping symbols. So the P stands for parentheses. And you will do anything in the parentheses first. Then, after parentheses and grouping symbols are out of the way, you'll look for any exponents in the problem and take care of those. Exponents would be like 3 squared. That means 3 times 3, which is 9. 4 to the third power would be 4 times 4 times 4, etc. That's exponents, that's the E. Multiplication and division, you'll notice I wrote them right next to one another. That's because they're on level playing field, I like to say. One does not come before the other. Yes, we say PEMDAS, and that's just because it sounds a little bit better, but it could very easily be PEDMAS if you wanted to. Multiplication and division, when you're reading a problem, if you have both of these, let's say there's both multiplication and division, you'll just do whichever one comes first when you're reading the problem from left to right. So let's say you had a problem that was 3 times 4 divided by 6 times 2. Well, there's multiplication and division. One doesn't come before the other. You would do this first because it's first in order from left to right. Then you'd get that answer and you'd divide, and then you'd get that answer and you'd multiply. So multiplication and division, you always do in order from left to right. I'll put an arrow pointing from left to right. And then the last two, addition and subtraction, work the same way. You're going to do them in order from left to right. So if you had 3 plus 2 minus 6 plus 4 minus 3, just go in order from left to right. You'll do this, then this, then this, then this. So let's put that into practice. Starting off very simply, we got 9 and a half minus 3 and 1/10 times 3. I know that not everyone likes to show work. It might feel like, oh, I've got to do so much extra, but it's not that much extra to indicate to people what you're doing first and showing line to line what you're doing. So what I mean is I've got two options here. I could subtract first or I could multiply first. Order of operations says that I need to multiply first. So I'm going to underline this. I'm going to be doing this multiplication problem first. Now maybe you need to go over to the side and actually work out the multiplication. That's fine. Do your scratch work on the side. But in the actual problem, underline what you do and then take that answer and replace it in the problem and just bring everything else down. So now I've got 9 and a half minus 9 and 3/10. And again, if you needed to do the scratch work on the side for whatever reason, do the scratch work on the side. But this is the next thing that I'm doing, and it's going to bring me to my final answer of 2/10. And we'll circle that. That's our best possible final answer. Now, if you had subtracted first and then multiplied, you would have not gotten 0 and 2/10. You would have got a drastically different answer. So make sure that you are following order of operations. It's not optional. It's not like, oh, I'll still get the same answer. You have to follow the correct order in which you operate within an expression. Figured let's go amp it up right away. Let's go to the big stuff. So I'm going to write my order of operations over here on the side, just as like a checklist. So there's no parentheses or grouping symbols. There's no exponents. So now I'm at multiplication and division, which there's plenty of those. Remember, those go from left to right, and I'm going to do this division first. That's the first thing I need to do. So maybe we'll work this out on the side. 4 and a half divided by 3 is going to be 1.5. Okay, so my first part of the problem yielded 1.5, and I'm just going to rewrite the rest of the problem. Seems like a lot, it's not really, and it helps keep you organized and the person who's looking at your work organized. They can see exactly what you're doing. Next, I still have multiplication and division, and I'm going to go from left to right. So left to right, I would do this next. So 1.5 times 5. And that's going to get me 7.5. So I'm going to write 7.5 there. Bring every part of the problem down. And all right. I still have one multiplication left. You might have looked over it, but it's right in the middle here. So we're going to be doing that next. 3.2 times 0.2. And I need to move my decimal point over 1, 2. So 1, 2. That gets me 0.64. So I'm going to replace that in the problem. Okay, and there we go. The next thing in my order of operations is addition and subtraction because I've finished multiplication and division. So remember, you got to go from left to right, which means I'm going to be doing this subtraction before I do that last addition. So on the side, you might want to do it 7.5. And remember, for subtraction and addition, you need to line up your place values, which means I'm going to need a placeholder 0. I'm going to need to borrow. And I'm going to need to borrow again. And I get 6.86. And the last thing here is to obviously add. So actually, I'm just going to tack that on to the end of this problem. 6.86 plus 1 and 1400ths. Okay, and I get 8 on the dot. So my final answer is 8. That's correct, and I hope that you take the time to start to write your problems like this. I know it might feel like so much work, but it's really not, and it really helps to keep you checking yourself. You could go back through and say, all right, I divided first, that makes sense. Then I multiplied, that seems like the right thing to do. I got rid of this multiplication, check. I subtracted, and then the last thing I had to do was added. So you can even go back and very quickly just make sure you did go in the correct order. Now, of course, you might have made a silly mistake in the side work. That's okay, it happens to the best of us, but at least this shows that you were going through the correct order in which you were supposed to operate. So one other example, then we're done with this. I wanted to show one like this. I'm going to read the problem out loud. This says 3 to the second power, or 3 squared, times 1.4 plus 1.6 divided by, this line here means divided by, kind of looks like a fraction, but it's also another way to write division problems. So divided by 5 minus 2. Now, I picked this problem for a specific reason. Anytime you have division that kind of looks like it's written as a fraction, this problem could be rewritten. I'm going to rewrite it like this. It could have been rewritten as 3 squared times 1.4 plus 1.6. And it's this whole thing. So that's why I put everything in brackets. You'd have to do this whole thing first and then divided by 5 minus 2. Notice I have parentheses around the 5 minus 2 as well. Because if I didn't, it would be divided by 5 and then minus 2. But we're doing this whole top, the top part of this, divided by the whole bottom. So anytime you have a problem written, it kind of looks like it's in fraction form. You need to solve the whole top first using order of operations. Then you need to solve the whole bottom using order of operations. In this case, there's only one operation. And then you'll divide top number divided by bottom number. So it's almost as if you could treat it as two separate problems that you will then bring together when you're all said and done. But we're going to do the top first, then the bottom, and then we'll get our final answer. On the top, I've got parentheses first. So in my checklist, parentheses, and then we'll take care of that exponent. So in the parentheses, 1.4 plus 1.6, we're going to do that first. And that's going to get us 3. 1.4 plus 1.6 is 3. The next thing we're going to do is we're going to take care of our exponents. That'd be the next part of our order of operations, and that's 3 to the second power, which just means 3 times 3, which is 9. Okay, and remember I said you've got to do the whole top first, so we're going to finish off the top. 9 times 3 is 27, so we're doing this next, and we're getting 27 over 5 minus 2. And 5 minus 2, that's easy. 5 minus 2 is just 3. So now I've got 27 over 3. And this is a division problem, so 27 divided by 3 equals 9. Final answer. And I'll just scroll up real quick so we can look at what I did. We've got parentheses first, we got 3. Exponents next, we got a 9. 9 times 3 to finish off the whole top part of the problem is 27. On the bottom, we had 5 minus 2, which is 3. And 27 divided by 3 equals 9, and that's our final answer. So order of operations, please take your time. And I mean, it makes so much sense to take the time to build good math habits. A good math habit is to start writing your problems like this, where you do one line, underline the step you did, rewrite the problem. Underline the step you do, rewrite the problem. Underline, and keep going. And it's fine to do all your scratch work on the side or whatever, but I would totally get in this habit. It's a good thing to do, and it's going to come in handy as you progress higher and higher through your mathematics classes in life. Either way, if you got questions, reach out. Otherwise, bye-bye.